Here we are, 5.6a, and this is an application section. And so what we're going to do is we're going to take a lot of the stuff we've learned in the last few sections and put them together in story problems, which makes life miserably wretched for some of you. And I know I never enjoyed story problems, and they're still not my favorite. But hopefully we can go through each of these examples, which I think there's 5 of them, and make them somewhat doable for you. So let's start with example 1. We've got one number is twice another. So we have one number, and we have another one that's twice the one number. So those are our two numbers that we're looking at. The sum of their reciprocals is 2. What's the reciprocal of x? The reciprocal of 2x. And it says when we add those two numbers together, we get 2. So what we're asked to do is find out what those numbers are. So we need to find x, and then we can plug in and multiply by 2 and find the other number. All right, so first of all, according to what we've done before, we have to find common denominators. And the common denominator is, well, we have a 2, and we have an x that's common. So our common denominators are 2x. So we multiply times each of these. So no quadratics here. So then we can cancel, and we get 4x there. So we have 2, because that one didn't cancel, plus 1 equals 4x. So 3 equals 4x, divide by 4, and we get 3/4 for x. Our other number, so our one number is 3/4, our other number is 3/4 times 2. So 3/4 times 2 is 6/4, and if you reduce that, it becomes 3/2. So our numbers are 3/4 and 3/2. And that's it. All right, so that's the easy example. We start getting into some of these other examples. And one of the things that the book does that I wholeheartedly agree with is making some kind of table. Always makes it easy, especially if you're dealing with distance, rate, and time. So if you remember, distance equals rate times time. So let's make our table here. We've got 2 families. So we're going to write first family and second family. Go ahead and erase that so I have a little more room up there. And 2 families, the first family's driving makes it in 400. Okay, so the distance is 455 miles. And they give us a speed, and they want to know, they talk about time. The second family takes a half hour longer to make the trip. What are the speeds of the 2 families? So that's what we end up looking for, is the speed. Okay, so we have the distance. We are looking at rate or speed, and we're looking at time. So let's look at what we've got here. So the first family makes the 4. Okay, so both families are going 455 miles. So we're just filling in the table with the information they give us. Speed. Let's see, the first family is going 5 miles an hour faster than the second family. So if the second family is going this fast, the first family is going that speed plus 5. So they're going 5 miles an hour faster. I don't know why that makes a difference, just because they have a newer vehicle, but that's what they've got there. Time. Time, okay, I had on here distance equals rate times time. If I solve this for t, divide both sides by r, those cancel. So my t is d over r. So really to find my time here, I just have to have my d over r. And the bottom one is d over r. Okay, so I've got my entire column filled in, or all of my columns filled in. One of the things that we have to have in order to solve one of these is an equal sign. So what we're doing is we are comparing distance over 8, because that equals time. That's what we're looking for, is time. But we're also looking for, the book wants us to find the speeds of the two families. So x ends up being the speed. So we're trying to find out what x is, so we can find out how fast this car went, and then add 5 to it to find out how fast that car went. So is it possible to take 455 over x plus 2 and make it equal to 455 over x? Are the times equal to each other? No, the times are not equal to each other. Oops, I'm sorry. Why did I put a 2 there? That's a 5. Okay, the times are not equal to each other because this first family gets there a half hour sooner than the other family. So if this family is getting there a half hour faster because they're going 5 miles an hour faster, they're not equal to each other. How would I make them equal? Well, I could make them equal if I slowed this one down by a half hour. Okay, so if, for instance, this car did it in 6 hours, this car over here did it in 6.5 hours. So if I want to make the times equal to each other so that I can make the equation equal, I'm going to have to add that half hour to the faster vehicle's time so that it ends up being the same as the slower vehicle's time. So I've got to remember to add that half hour, because see, what I'm doing is I'm comparing the times. I've got to make something equal. So if I want to make them equal, then I have to get the times the same. So that being the case, then I've got this, and this as common denominators. So I'm going to have to multiply this whole thing by 2x times x plus 5. Okay, got my common denominators there. So let's go ahead and write that all out. Okay, so let's cancel that with that, that with just the 2, and that with that. So that gives me 2x times 455 plus x times x plus 5 equals 2 times x plus 5 times 455. Got rid of all of our fractions there. So this ends up giving me some bigger numbers to work with, being 9, 10x plus x squared plus 5x equals 910 plus 4,550. You do the FOIL method and then multiply that by 2. And you end up getting 910x plus 4,550. and we manipulate things around. Our 5x stays there, minus 45, 50 equals 0. And then we make our parentheses, two numbers multiplied together, give me 45, 50, and added, give me 5. And I'm just cheating here and looking at the book. So my x is negative 70, or x is 65. So since we are talking about speed, we know that this one doesn't work because it's a negative speed. So I know that the one van is going 65, and the other van, because it's newer, is going 70. And that ends up being where you're at there. Okay, let's jump to example 3, the boat in the river problems. These are the nemesis, or the death to all math people. So we've got this current of the river, have to use blue, and it's going 3 miles per hour. It takes a motorboat a total of 3 hours to travel. I'm going to make it a sailboat. I can't make motorboats. It takes it 3 hours to go 12 miles upstream, red, and then another, and back. So we've got 12 miles, 24 round trip. What is the speed of the boat in still water? So what is the speed of the boat without the current? Okay, so we're going to do another table. So we have up and we have down. And again, we're doing the distance, the rate, and the time. So the distance upstream is 12, and it's the same distance back downstream. The speed of the boat. What is the speed of the boat in still water? So the rate in still water, we're just going to call the rate is x. So that's in still water. When it goes upstream, we're pushing against a current of 3 miles an hour. So my rate is going to be the speed in still water minus 3. We have 3 mile an hour pushing it. Our speed going downstream is the speed in still water, but instead we're adding 3. So again, we're trying to find time. So time equals distance over rate. So our distance over rate here, and our distance over rate here. So it tells us that our time to go up the river, or what do we do? Up the river and then back down. You add those two times together and you get 3 hours. So our time up the river plus our time down the river is going to be 3 hours. So we can write that very easily as equals 3 hours. Okay, so that being the case, I'm going to make some room here. We're going to multiply the entire thing by, what is the common denominator? X minus 3, x plus 3. And again, the only reason you do that is because we're trying to get rid of the fractions. Okay, so use black here, that and that, that and that, and nothing crosses out there. So we have 12x plus 36 when we distribute the 12 there. We have 12x minus 36 when we distribute across there. X minus 3 times x plus 3, that is the difference of two squares. So let's go ahead and put that there, times 3. So that gives us 24x. The 36 is cross out. And let's distribute that on the right. And then I can start bringing things together. So what I'm going to do is I'm going to move that minus 24, or that 24x over to the other side. So I get 0 equals 3x squared minus 24x minus 27. Then I can factor out a 3. Okay. One of the things that you need to realize when you do this is when you factor that 3 out, it really kind of goes away because it's equal to 0. So when that's the case, you can just make it disappear. So you don't use it anyway. I mean, I guess you could leave it there because when you do this, x minus 9 and x plus 1 equals 0. And if you had the 3 there, it's not going to change because all we care about is what does x equal there or x equals there. And we just kind of ignore the 3. So one of the things, it's again, because we're talking about speed with x, is we can have a negative x or a negative, speed. So our speed is 9 miles per hour in flat, calm water. And that's it. All right, I'm going to shut this down, go into the next video.